Got it. Let's see. Okay. Hold on a second. Let me just. Got it. Okay. I'm sharing my screen now. If you can't see, just draw my attention. Great. Go ahead and play. Okay. Hello, everyone. My name, as Maka mentioned, is Michael Emmanuel Ebo Texan, but people I know normally call me just Ebo or Texan. Today I'll be talking about introduction to database with MongoDB. So I'm guessing the basic idea that we'll be talking about here, considering we are looking at MongoDB, is like databases in terms of NoSQL or NoSQL. So we'll be talking a little about that, some architecture considerations that are kind of specific to NoSQL, and some assumptions in the CAP theorem, just some basic. So we'll talk about some strengths and weaknesses of NoSQL, and then we talk about MongoDB. I hope we can briefly wrap through this. So maybe you can ask questions, because I think that's probably where we'll have more interaction and lots of learning will take place. All right, so I will begin. Okay, right. So yeah, basically there are lots of things or lots of terms that will be thrown around when you are learning something new. Sometimes it's good to bring this up front. So I'll briefly talk about, say, key value. I'm sure most of you have probably heard of the term. When you think about, say, a JSON structure, or if you're familiar with JavaScript and you look at a JavaScript object, you basically have some kind of key value pairs. It's the same concept we use in dictionaries in Python, or basically when you want to retrieve a value given a key. That's the basic idea. And you see a lot of that thrown around in NoSQL. You hear about graph databases. Some graph databases that you might hear about, say, would give you some kind of idea about how these are connected. So when you think of a graph, you have a set of nodes connected by edges, and then these nodes or vertices have contained certain data points, and then the edges are connected to each other. So we could, when you think of the idea of a social network, it can be easily modeled by a graph. Therefore, if you would want to do some kind of analytics on some social network of sorts, it would be best to use a graph database. So this idea gets tossed around a lot, especially when you're talking about NoSQL. Document-oriented. So we get to see a lot about what we mean by documents and then how this applies in the case of MongoDB. And there's also the term column family. And that's also something you'd hear. There are column family databases, and this contains like columns of related data. That's basically why we call it a column family, or a family of columns. Now, yeah, just something to basically toss about. It's called the CAP theorem, right? So if you've dealt with like systems a lot, you would realize that you cannot, there's Eric Brewer in 2001 mentioned that you cannot limit the number of faults, and any number of requests can be, if you cannot limit the number of faults, and any number of requests can be directed to any server, and you insist on serving every request you receive, then you possibly cannot be consistent. The basic idea is that you must always give something up, right? You have consistency, availability, or tolerance to failure, and then reconfiguration. So it's either your system is very consistent and available and has very little configuration, or you take away the availability or fault tolerance, and then you have consistency and reconfiguration. There's always, thinking about it, there's always something that you might have to give away. I don't know how many of you are already familiar with databases, especially SQL type databases. relational database management systems, you will get the sense that there's some kind of there are some kind of problems that are very well managed by relational databases, and there are some problems that would be very difficult to model by these, and that's gives you the idea that you always can't like get everything in terms of consistency and availability or reconfiguration with a particular database management system. And so some still on the topic of terms and terminology, we'll talk about sharding of data. Then in this sense, sharding is something that's also used in relational database management systems. So basically you have, let's say you have a big block of data, right? And for some reason you want to be able to spread this data over multiple systems so that accessing all these various blocks of data would be simple and easy. So you have a very big database. Sometimes what companies sometimes suffer with is they have a really huge database, and querying that database takes a lot of time. So sometimes the question is, how do you break down this data set so that when a request comes through, it will be routed to the specific, we call it shards, right? And it's doing this from the first point says it distributes a single logical database system across a cluster of machines, right? And then there are different types of partitioning that you could use to distribute the data that you have. So the question is, are you going to partition your data sets, each table, first 100, second 100, third 100 across all these clusters? Or are you going to partition them according to users or several other characteristics? So this idea gets tossed around a lot because NoSQL databases are designed with sharding in mind. So it makes it much easier to query databases that are to query data from the same database if they are even stored across multiple clusters. And this NoSQL also enhances this, takes us a bit further by allowing you to either like turn this on or off and automatically balancing the load that you have on each of these clusters, which is a very interesting point. We also have the idea of replica sets, which is also baked into these NoSQL kind of databases. So it's basically a replica, just like the name suggests, right? You have the redundant objects of these databases that you previously had. And there's also failover in case one of these replicas goes down. You can do some kind of master-slave replication, which is also something that you have to put in some kind of extra effort to do on a relational database management system, but it's much easier to achieve these when you are running a NoSQL database. Also has geospatial features, considering if you model location-based problems as a graph, and when you think of the graph databases that we talked about, one point on one location to the other, some of these NoSQL databases are good with that. Yeah, so we keep tossing around NoSQL, RDBMS, right? So basically we have that idea that you have a store of data. That's just basically it, right? A relational database management system, a NoSQL database, they basically are like files and folders on your machine, like deep down in the core, right? So it all depends on how you write a set of scripts to logically manage these files. So if you think about it, if you're familiar with RDBMS, you just think, say, you have a folder, and in each folder you have a name. In each folder, there's a file with a certain number of lines of data. Basically, at the core, this is how they operate. It's all based on the file system. So these two are somehow seemingly alike, but then you can have some kind of like the construct that has been built on top makes them different. So we'll be talking about like the differences in this slide. So when for the NoSQL databases, they have some kind of loose schema definition, right? The problem with, or not the problem, was like a feature of RDBMS is that you need to define the models that you are going to use, right? You need to define your tables, you need to construct them. What data type should this column have and all that. But NoSQL is kind of free. So if you've ever been in a case where, especially if you're writing like Django migrations and you add one field to the table and then you have to come back and make it not null, and then you have to write a change and run migrations. All these are tracked, but it's something that's very hard and as you well know, could get very complicated. So the loose schema definition of the NoSQL here makes it much more appealing to people who don't like that kind of problem. When we say schema definition, we basically generalize it to the tables that you have or the database that you're generally dealing with. Yeah, okay. So another thing about the NoSQL database is that applications are written to deal with specific documents or data, right? So the applications are aware of the schema definition. The applications that you write to connect to these NoSQL databases already have some kind of semblance of what you want your data to be. So usually your application will have some kind of person entity, and then this is what you use to connect and create data in the NoSQL database. And if we look at RDBMS applications, so you usually have these, right? But then we need to therefore create the corresponding matching database on the tables in the database, which isn't something that is fun doing all the time. And remember, we talked about sharding, which is basically splitting up the huge database and distributing it across a cluster of machines. And NoSQL databases are designed to do that, right? And also, there are some trade-offs, right? It's not exactly free lunch that you get when you're enjoying all of these with the NoSQL databases. One of these trade-offs is it doesn't have much support for querying. If I'm writing, if I'm building an application with a database, say PostgreSQL, which is a popular relational database management system, or MySQL, I will be able to write queries through wrappers that are available to me in the language that I'm using, use their API if I'm more comfortable with that, or I will be able to go directly to the core and use SQL with some querying interface. I'll be able to use some kind of query language that is associated with the PostgreSQL has PSQL. That's something you could also use. So it has this much support, and that's something that you would want to get used to. Hold on a second. Just okay. So one other thing too is we have the case that okay. So let's go there. We have the relational database management relational database management system. So basically, database systems have this property we call ACID, right? That it maintains atomicity, it maintains consistency, it maintains isolation and durability, right? So these are properties that you want your queries and your constructs in your database relational database system to have. Now, this is a case where because we are getting so slack with some of these properties, and we're having to relax these ACID properties in an NoSQL database. And sometimes if you're missing some kind of consistency, then your application might suffer in some way. So these are also kind of trade-offs that you get. Like we mentioned with the CAP theorem, you can't have everything for free. Okay, let's go to the next. Okay, some benefits of NoSQL, right? So we talked about some trade-offs. Well, let's look at some benefits. There's elastic scaling, and this basically talks about having a, one moment. And 1 second. I'd like to go mute and answer. Cool.
Sorry about that. Mano, you can unmute.
Okay, right, thank you. Let me go back to, okay. Yeah, so I was speaking about benefits of NoSQL, started talking about elastic scaling. And yeah, so basically, when you hear the term elastic scaling, it's not like specific to NoSQL or what we're discussing here today. It's basically the idea that you will be able to scale a set of resources to meet your resource demands. So here, NoSQL also has elastic scaling. Our RDBMS, like if you have, say, PostgreSQL or MySQL, could scale up. So when we talk about scaling up, we mean you're adding more and more resources to the same server, right? And this enables you to handle bigger load, right? So basically, if you need bigger load, just get a bigger server. So if you're using 2 gig RAM at 100 gig of ROM of space, you should add more RAM and probably more space in order to handle your RDBMS requirements. But with elastic scaling, you scale horizontally. So you can add more nodes, and think back to the idea of the shards. You can have this database you can have this database residing on multiple machines. So that's what we call horizontal scaling, as opposed to vertical scaling or scaling up. Now, this elastic scaling is one benefit. With RDBMS2, you need to have some kind of experts or specialists to handle your database. So typically when you go to companies which have RDBMS, you probably have someone who's very familiar with managing database systems. If you're using something like Oracle, the person will probably be Oracle specialized or certified, and that means he's going to get paid more, and then it means when he's out of the job, then you need to look for someone or you suffer. So basically that kind of requirement is less. I'm not saying it's not completely gone, but it's less on the NoSQL side of things. And yes, the RDBMS can handle large data systems, right? Like volumes of data when you're storing and all. But sometimes querying can sometimes take a toll on the server. And think back, in this case where you have to scale horizontally, vertically. I mean, you can't add 200 like times the size of the original server back to that server. So for instance, if you have a 2 gig RAM server, maybe you can go up to what, like 36 gig, and that's it. Because you're scaling vertically, you're adding more resources, but there's a limit, right? But then if your database is suffering and you keep adding more and more and you hit that limit, you can go higher again. But NoSQL was designed to handle lots and lots of data. So if you keep increasing and you hit the 32 gig of the machine you are using, with NoSQL, you can add another 32 gig machine and another. And it's like the limit is just as much as what your budget can handle. So it's basically designed for big data. You have flexible data models. I can't talk of this enough. Your database models are not strictly defined. Your schemas are not strictly defined. So you cannot be like fixed into not being able to change your schema because the business rules changed. Change management for RDBMS has to be carefully managed. Like I mentioned, one way I've seen it well managed is in Django, where you do migrations. Other applications do migrations as well. So it sort of encompasses the idea that you need to keep track of the changes that you make carefully. And then when you make any mistake, it's like a lot will be ruined for you. Yeah, but on the other hand, NoSQL databases are more relaxed in structuring that data. There's also the economics of it, right? RDBMS sometimes expensive, not all the time. Some of them are free and open source, like MySQL, PostgreSQL, but then you realize that they have high performing ones that are sold, like Enterprise DB for PostgreSQL. So sometimes, and even the really good ones like Oracle and all are quite expensive to manage and use. And with NoSQL, you can just get clusters of like commodity machines, like general use machines, and then just run the servers on them. And this should be, in theory, should be able to work just fine. Okay, so now some drawbacks again. So support, right? The whole idea that RDBMSs are well supported. They have courses, they have certifications, and it's there for NoSQL's databases as well, but these are not as well recognized and they haven't been used for years. So when you look at the point about maturity, NoSQL relatively compared to RDBMS, they have been used for quite some time. So the support is very much there, and the maturity of the databases too. Especially in NoSQL, some of them are still in active development. So when you end up using them, using sets and functions, they might break, and then because a new change came in to take their place. All right, we've also talked about administration, lack of expertise, which could go back to the support. Yeah. All right, so we briefly touched on the ACID principles. Right, there's a similar set of principles in NoSQL databases, which we call base. So this table is basically just describing or giving the differences between the two. So RDBMS has ACID, which is basically atomicity, consistency, isolation, and durability. And NoSQL has base, which is basically available, soft state, and eventually consistent. So when you take a look at this and think back to the CAP theorem, you kind of see that, well, it doesn't have everything, at least, but then it's trying to be eventually consistent. It's not saying it has consistency, just like the consistency in ACID, but it would eventually be consistent. So you're seeing that it's doubling down, it's relaxing on the consistency. When you look at the ACID, you realize that it doesn't have availability because when you think about it, NoSQL databases can be sharded in multiple servers, onto multiple servers. So then when one goes down, the replica sets, another one will be available. So as compared to RDBMS, you don't have that kind of availability, right? So RDBMS is also relaxing on the availability, but it's replacing with something else like durability. So it's kind of a trade-off, and it's not that there is one database type that's better all in all compared to the other. It's usually very problem centric, and it depends on what kind of problems you are trying to solve. Okay, so now that we have some kind of background, we will briefly go over the NoSQL database that we'll be talking about today. With, I think, the chosen one that was described was MongoDB. So we'll briefly go over that. Again, some background on the MongoDB itself. They're developed by MongoDB Incorporated, but I think at the time they were called 10gen. They changed their names sometime in the process. 10gen was founded in 2007 and it was written in C++, right? Like most of these like hardcore systems, applications, databases, written in C++. It's document oriented, and we'll get to see a bit more about documents. It's a NoSQL database. So NoSQL is not necessarily MongoDB. I think some people get this misconception. It's a kind of NoSQL database, just like PostgreSQL, my favorite. It's a kind of RDBMS. And it has no data definition language. So it doesn't have something specific like SQL, and which means that it's basically helping you retrieve what you store, which is why that whole idea of key value pairs that we talked about earlier comes into play. And we have document identifiers, and they'll basically be created for each document, and then a field name for that document will also be reserved. And so instead of you defining your schema, the application or the MongoDB service, the application that you are writing to connect to your MongoDB service will track your schema and then where they are related to. So you have your person entity in your application, and then you just create and store objects and documents in the MongoDB instance. And it uses BSON formats. BSON formats is kind of like JSON. If any of you heard about, like, you're very familiar with JSON, and it's very handy document format for sending and retrieving documents or data. BSON is also kind of like JSON, just that it's in binary and it's very pretty fast. Right, some cool features of MongoDB this time. The dynamic schema inherits that from NoSQL, has no data definition language. I think there might be some NoSQL data systems that might have the DDL, but I'm not too sure about that. Secondary indexes, so you kind of have indexing on your data. So yeah, there is some kind of query language though, but you have to access that through the MongoDB API. And you can also sort of turn on atomicity, but although that's optional, and you can do like master-slave replication. And like we spoke about NoSQL having baked into them, like the idea of horizontal scaling, you can also do this. And then sharding as well, but it has no joins. Joins is something that's really cool in RDBMS, but you might have to forego that for this. Yeah, now why MongoDB? I basically have simple queries. So think of it as, let's say you're dealing with JSON, the JSON object that you create is basically that which you pull out, right? So you just create the query, you can have some kind of key indexing into that query, and then you can get the data out. It's really fun to work with MongoDB if you're very, very familiar with JavaScript, and it's kind of very close. Yeah, the MongoDB, yeah, so just like from the statement I last made, if you're building lots of web applications, MongoDB is kind of like would be second nature to you. You can easily pull and integrate data. You don't need to go through that trouble of writing ERD diagrams because ERD diagrams don't really make sense here. Yeah, some are okay. So just to think about it, Mongo, like in simple terms, a MongoDB instance may have like 0 databases or 1 or 2. So like 0 plus more of these databases. And each of these databases may have any number of collections, right, from 0 or more. And each of these collections may have documents in them. And each of these documents may have like 1 or more fields. So a document would basically probably not exist, but then when it exists, then it probably has a field in it. And MongoDB indexes work much like a relational database indexes. So if you have a really big table and you want to be able to search it faster, what you usually do with an RDBMS would be to index it. And that's kind of like the same idea. You can also run that on a MongoDB instance. So putting the two together, when you have an RDBMS and a MongoDB on the right, with RDBMS, you have like the database, it's also called database here, whether you have a table or a view, query that table, select star from this table, you basically have what we call a collection. And in each collection, a row would be a document in MongoDB. So the row where you define that for this table with a column, here's name, here's age, here's gender, that's like basically a single document in MongoDB. You're gonna have a column, which is a field in that document, which is why like if a document exists, you should have at least 1 field. Indexes are the same, joins are referenced as determined as embedded documents. And we have foreign keys as references. Partition here in MongoDB is typically called a shard. But funny enough, in RDBMS, we call partition in databases sharding. So I know. Okay. MongoDB processes and configurations. When you install MongoDB, what do you basically get? Like when you have a MongoDB instance running, if someone asks you what like this MongoDB instance is running, or how do you know like which parts there are and what's the connection between them? So you basically get like the MongoD, right? That's like the database instance that's running. It's a daemon that runs in the background and like operates the MongoDB system that you have sitting on your machine. You also have MongoS, which is the sharding process. And this basically, it's kind of like a router in a traditional database sense. And whenever there's any kind of request, because we have shards because we have shards of this database, it could be a single shard, could be multiple shards. The MongoS would basically take the requests that are coming, what queries, and then route them to the appropriate shard to get the data you need, right? And it decides how many MongoDs should receive the query that's coming, whether it's a single one or several of them. And then you also have Mongo, which is the shell client that you need, just like you have PSQL, which is some kind of shell client that you need to access your PostgreSQL database. You also have Mongo. You can have one MongoS per multiple MongoD, or a local MongoS per like a single Mongo client. So like you have for each Mongo client that you have, it has its own MongoS running. So there's no limit to that. Yeah, BSON formats, a really fun, interesting one that it's so it's binary encoded. That's the format that the documents are in. So it's binary encoded, like JSON document or so. Just think about it like it's JSON, but it's really the data type that's of interest here. Since it's binary encoded, it's easy and faster for the machine to read, display, transfer that data as compared to like if it was actual JSON, which would have been like really heavy considering you have several documents per collection. And each entry consists of a field name, a data type, and a value. So that like when you think back to when you picture JSON object, you realize it has a field name, has a data type, and has a value. It has a field name and a value, so it's like key value pairs. But then in this instance, we also consider the case of having a data type, and this data type sort of determines whether we're looking at an integer or a text. Now, large elements in a BSON document are prefixed with a length field it helps facilitate scanning. So normally you would want to scan and find out, like pick out certain documents. You like to scan a table for indexing. You like to scan for several other reasons. So if there's a length, it helps with like the pre-calculation. How long is it going to take to scan this entire table of records? How long did it take to do like all that information? It's helped by the BSON format. So it's quite a nifty feature that was chosen for the NoSQL databases, and that's proven to be quite helpful. Yeah, so we'll take a look at this diagram that basically depicts the schema structure of a document, right? So we understand that there are no nulls. Like if you've ever used RDBMS consistently, you'd realize that we don't have, there are cases where you don't have any value to put into like a record, right? So you create maybe middle name field in your table. That's a bad idea, but just let's say you create middle name field, a column in your database table, and then it turns out that not everybody has some kind of middle name, right? We probably have a first name or a last name, but not a middle name. So then that raises the question, what do you put there in the middle name? Some people put like the empty string, some people put different, all sorts of things. But typically what you might find there is a null. And nulls like can be problematic. And that's like some of these challenges that people deal with the relational database management system. So when we come to NoSQL, you basically don't deal with nulls, like just forget them, pretend they don't exist. So these documents show typically what could be the same, there could be documents, multiple documents in the same collection, right? So we could have where name is Brendan and aliases are given in the one on the top right corner. The one below that has name, but doesn't have aliases. It has pizza, height, location. So it also helps like restrict it also helps like limit the size of the table or the data that's contained, because here you don't have fields that are empty. Just like in relational databases, it would have you define what the length of that field will be so that it can still create it even though you have it now there. And that's also takes maybe some minimal amount of space, but space nonetheless. So all these are things that are pretty fun to use when you're working with MongoDB. Okay, so I'll just briefly rush through some ways of creating like documents, updating them, and the rest, basic CRUD operations. That's what we will look at. Yeah. So basically, a database basically just runs CRUD operations, right? Create, read, update, delete. That's the basic functionality of a database. It creates, reads, updates, and deletes data. So in this sense, we're looking at creating, reading, updating, deleting documents. So we have, for instance, if you want to create, you basically have access to that database in whichever language that you are writing with, right? And if you're familiar with JavaScript a bit, you see this dot notation that you typically use to access properties of objects. You can use that same thing here. So you have DB collection, where collection is the name of, should I say, the table that you are trying to access. And into that table, you want to insert some document. So the document would be your key value, pair, object, that you'd be assigning here. And you can do the same thing when you're saving. You can do the same thing with a property called save. And you can do the same thing with the update. And with an update, you're updating based on some query that you're passing, and you want to pass what you're updating. And there's another field that we use, it's called the upset. And you can also pass this upset as true or not. Upset is kind of like, if it's not there to update, which is what you are doing, you can insert, and you set that to true. Yeah, there are also some other read operations that we might want to look at, which are db collection.find. You could use that to query for some kind of document that you're looking for. And that could look for several documents, or you could do find one, which could be your query for a single document. You could, sorry. Yeah, so we have the same, specifically for updates, you could be doing this with the update command and pass several options like upset. You could also pass some of them as well. And you could also do the same thing with delete. And that's, yeah, that's also similar to your mutable operations updates. And you can also pass options. You have a query, and then you have your update fields for that document. So yeah, I think I will end here to give some time for questions. If anyone has questions they'd like to ask, or anything specific you'd like to know.
Right, thank you, Emmanuel. Okay, guys, go ahead and ask your question. You would need to raise up your hand. Can you raise up your hand and you take your questions? Or you can drop your questions in the chat. Okay, so I'm not seeing any questions yet. If you understood, kindly drop you understood in the chat so that we'll know what's happening or where he can go back to. If there's a part of his slide you didn't understand, go ahead to ask your questions. So, okay. So you just ask your question. Do you need to unmute to ask your question, or raise your hand if you need to be unmuted?
Okay. Okay, I think Mohammed dropped a question. What's the best use case for each RDBMS and NoSQL? Okay, so typically, let's say we're thinking generally, right? In cases where you have clearly defined business rules, and basically what you are performing are transactions, that's like the general idea. You will go with, like, you should probably go with an RDBMS. So a typical example is, let's say you are modeling some processes that exist in a school. Okay, so in let's say a primary school. So in a primary school, you have students. Students are clearly defined. If somebody does not meet certain characteristics, they are not a student, right? That's and the processes that a student goes through, they attend class. Class is taken in a room, and this room occurs, this transaction occurs within certain periods of the day. these are clearly defined rules, and you can sort of frame or define models or schemas to undertake these processes or transactions. That would be a typical good scenario to use an RDBMS. But take, for instance, a case where you are trying to understand the relationships between certain people and then the times that they go to work or take some kind of medicine, right? You basically have this idea that these are people, but what are some of the characteristics around them, right? You basically have no idea. So you can just say, okay, you have the person's name, and then you create this object. Gradually, as you go on, you realize that there's a connection between these people and, say, pharmacies. Then you create a pharmacy, and then you kind of put that relationship in between them. This is something that you are not aware of the relationship directly. So as you're going on, this keeps getting improved and built on significantly. It's not like minor changes that you might have in an RDBMS, because the processes that you are looking at are not clearly defined. The connections that you are willing to play with are not clearly in place. So that's like one way of looking at these. If it's a transaction or a process that's clearly defined, and you might probably do well with like RDBMS. If they are mostly doing transactions themselves, then you could probably go with an RDBMS. Mm-hmm. No, when I say transaction, I mean, so how do I put this best? So let's say, okay, so let's say you have a database system, you are storing data, right? You either do something with that data. That something is what I'm terming as a transaction. It's either you are creating more data, you are taking one data, adding it to the other, and like pulling them together in some, it's an operation. Yes, basically an operation, right? And if you can perform these operations in a way that are independent of other operations, then we can call that single unit a transaction. So me creating, let's take the student example. Me creating a student will require that first I have a person who is in a school. So creating the student is basically first creating a person, finding out which school they are, putting these two together, right? And then coming out with a student. So that's a single transaction, creating a student. It involves multiple transactions, but it involves some operations, but these operations can be seen as a single unit. That sort of makes it a transaction in the database sense. Yep. Any other questions? Yes, your data could be, yes, your database could be quite large. You know that you assume your database could be large, right? But you don't have a clear picture of how large it could be. You could use NoSQL databases, but I think large is one case. How about, let's say, also the case where we discussed about horizontal scaling, right? So large can be considered because you don't know whether if your database keeps growing, you'll be able to add more resources to the server to hold the querying and all the transactions going on, right? Would it be better if you did horizontal scaling? In that case, it would be best if you had no SQL database, because that would help you, right? So one, the structure is less rigid in NoSQL. So if you don't have clearly defined structures or schemas, you should probably go with NoSQL. Also about like querying, you don't know how big your data might grow and you think it would become very big. So in that case, you might need to do horizontal scaling therefore you would have to go with, like, you may have to go with NoSQL. Great, like, happy to help. Okay, so scaling is basically increasing the resources or performance of a system, right? So if I say scaling a database or an application, I mean increasing the resources and performance of that application. One way of doing that would be to add more, say, RAM or more space. If you want to increase the performance of your laptop, you buy more RAM, you buy more space. Or another way could be to add another system. So I want to increase the performance of my system. I have one machine. Okay, if I add two machines, that will increase it. That is called horizontal scaling. So I add more, increase the number of systems entirely. Horizontal scaling, increase the number of internal components, RAM, ROM, and all that. That's vertical scaling. And this is all done to improve the performance and resource usage of the system.
All right. I hope that answers your question, Mohammed. So if there are no other questions, we'll say thank you, Manuel, for coming on this class. We so much appreciate it. It was a pleasure having you.
Thank you for having me.
All right.
Right. Thanks, guys.
Okay, guys. Good night, everyone. Have a lovely day. And thank you once again, Emmanuel.